In this lecture, we're going to talk about groundwater, which is water underneath the ground that we're able to tap in to and use as a valuable resource. So let's start by talking about how groundwater is distributed. If we look once again at the volume of water on the surface of the earth, we can see that almost all of that volume, over 97%, is held in the oceans and is pretty much unavailable for humans to use as a freshwater source. We can distill it, but it's expensive and time-consuming. So we tend to rely on the freshwater sources shown in the other pie chart here. Of that, by far, the biggest percentage of that is tied up in glaciers. And those glaciers are, of course, ice, and they tend to be located very far from where humans are, such as Antarctica and Greenland. However, the next biggest slice of that pie is groundwater. And groundwater is a significant portion of the fresh water that's available to humans on the surface of the earth, much more so than what we find in the rivers and streams and use for freshwater consumption. Another important thing to remember about groundwater is that it's slowly filtered through the ground. So not only is it a big volume, as is shown here, of water, but it tends to slowly move through the ground. On average, that's about 280 years from when water infiltrates into the ground from precipitation and is finally used by humans by pumping it out of the ground. In Bend, that time is much shorter. In Bend, it's about 10 years between when the snow melts in the high Cascades and when water is pumped out of the ground for municipal use in Bend. Bend's water supply comes from both groundwater and from surface water. There's the Bridge Creek watershed up towards Tumalo Falls that we use as a freshwater source as well. I think when some people think of groundwater, they think of something like this, that if there's caves underneath the ground and those caves are filled or partially filled with beautiful clear water, and it's very picturesque and beautiful, and there is some groundwater that occurs this way, but it is a very, very small percentage of the total groundwater that we find in the ground. Most of the groundwater is distributed in very small pores or openings in soil or sediment between individual pieces of sediment, or it could be as like cracks in the rocks. So wherever there's a little bit of empty space underneath the ground, the water tends to fill in. And then the water moves very, very slowly through those spaces, and at the same time, it's being naturally filtered. So groundwater it has its contaminants naturally removed by the soil and the rocks that it's moving through because the spaces are so tiny. So it's just like a natural filtration system. It takes a long time, but it's a valuable resource because it's fresh water that's available underneath the ground. So really when we think about groundwater, it's better to think about it this way. If this is a surface of the earth shown in green here, of course we have surface water available to us as rivers, and we can get water from those rivers, but there's a much bigger volume of water underneath the ground. And if we go far enough underneath the ground, we get below this thing called the water table, and that's where we go from gray to blue here. And as we can see, it kind of intersects with the river, and we get a smaller water table up here. We'll talk about that later. But as water falls on the ground here, it gets filtered through this area here where there might be a little bit of water clinging to the sides of particles, but all of the empty spaces between the particles are not filled in. That's called the zone of aeration or the unsaturated zone. If we sunk a well into this zone and tried to pump water out of it, we would be unsuccessful. You just can't pull the water off of these little grains. It's just kind of coating the grains. It's not filling up all of the empty spaces. However, once we get into the zone of saturation, if we had extended this well down into the zone of saturation, we would actually be able to pump fresh water out of the ground.